In task 3, you perform titrations in order to find the water hardness of the untreated well water samples and the treated slash remediated well water samples. So make sure you write down the sample number, either 1, 2, or 3 here. And for the untreated well water sample, you did 3 replicates, and each replicate, of course, there's the end point volume of EDTA in milliliters. Make sure you record it here. And same for treated slash remediated well water sample. So you did 3 trials, and there should be 3 endpoint volume of EDTA used. So the complicated part is how do you find out the concentration of calcium 2+ or water hardness as calcium carbonate. So before we move on, so actually EDTA will bind with magnesium 2+ and or calcium 2+. EDTA is not very specific, just for calcium, so just a little bit of background information. So anyways, since EDTA is not specifically for calcium 2+, and we'll use this M 2+ to symbolize that it can either be magnesium 2+ or calcium 2+. But of course, usually it's mostly calcium 2+, but we don't want to exclude magnesium 2+ here. Anyways, so in task 3, you did 6 different titrations, and whenever there's titration, think about M1V1 equals M2V2. So I modified M1V1 equals M2V2 in this form. So now I use this abbreviation here as subscript, and the other side I use EDTA because obviously we used EDTA to titrate magnesium 2+ and slash or calcium 2+. So here obviously we're looking for the molarity of the cations, and if you recall, you used 5 milliliters of well water sample, so we'll use that as our volume of the cations. And the EDTA used was 0.001 molar, and the volume of EDTA here is obviously whatever value you have here. And after that, you can calculate this value. However, the molarity, this value is in molarity. Here, you actually want the values in either ppm or in milligrams per liter. So whatever molarity you get, multiply that by 10,000 or 10 to the 5th power, and that should be able to give you a number that's in milligrams of calcium 2+ and slash or magnesium 2+ or calcium carbonate per liter, or in ppm. They're the same units. So water hardness is usually expressed as calcium carbonate in ppm or milligrams per liter. So whatever value you get here, simply copy that value and record it here. There should be the same value. And do the same calculation for each trial here using this approach. And the equation in red. And after you find out the molarity, multiply by 10,000, and you'll figure out the concentrations here. And here. So so actually here, it's not just calcium 2 plus. It should be calcium 2 plus and / or magnesium 2 plus. But again, it should be mostly calcium 2 plus. But we don't want to exclude magnesium 2 plus. Just a little bit of background information. Okay, so the water hardness in the well water sample, or specifically untreated well water sample, the first value they want here is simply the average of water hardness. So in parentheses I put 3 replicates of untreated well water. So 3 values here, take the average. So add the 3 values, divided by 3, you can get this value. And the same for the remediated sample. You end up with 3 values here, add them together, divided by 3, and you should be able to get an average of water hardness for the 3 replicates of treated or remediated well water. After the plus and minus sign, simply find the standard deviation of water hardness of each. So take those 3 values and then find the standard deviation here, and take those 3 values and find the standard deviation, and you can record it after this plus and minus sign here. So you can either use an online calculator for standard deviation. You can use your calculator. You can use Excel. Or if you took stats before, you can use the equation for standard deviation and do it by hand. So whatever way that's the most convenient for you. Okay, so again, the percent reduction of water hardness after remediation. So it's the same approach as task 1 and 2. For fluoride, iron 2 plus / iron 3 plus, same approach. You want to know the difference between the untreated sample and the remediated sample first, divided by the untreated sample and its percent reduction. So always multiply 100%. So that's task 3. So let's go to task 4. So in task 4, you obviously remediated your well water samples. So the first part, outline your remediation plan, being sure to fully specify all variables in your process. So for this part, I want you to outline. So feel free to use bullet points. I think the easiest way is to separate it by different tasks or different type of ions. So obviously there were 3 different type of ions. Number 1, fluoride. Number 2, iron 2 plus / iron 3 plus. Number 3, water hardness. You can either express it in calcium 2 plus / magnesium 2 plus or calcium carbonate. However you want to express it. We can just simply say water hardness. But anyway, just write some bullet points. List the steps that you took to actually remediate the water. You used the batch method, and what did you do with the batch method? Which agents did you use? And just make sure you're very specific about which ones used for which type of ion, and how long did you take, what did you do, and so on. And the final evaluation of the remediation protocol after testing the products. So obviously for all the tasks, you found out the concentration of the specific ion in each task after it was remediated. Of course, for task 1, only people with sample number 3 can comment about how effective it was. But for iron 2 plus, iron 3 plus, and water hardness, you can comment about how much of the ion was reduced after remediation, and if you achieved the goals. So if you turn to page 152 of the lab manual, actually there's a under step 1 of experimental procedure, you were told that the goal for each ion, for fluoride, you want it to be less or equal to 1 ppm, and for iron 2 plus / iron 3 plus, you want to reduce it to 0.3 ppm or less. For water hardness or magnesium 2 plus / calcium 2 plus, the total hardness level should be between 60 to 100 ppm. So according to your result after remediation, you should be able to evaluate how effective the remediation protocol was that you basically outlined here.